EWC Controls, manufacturer of residential light commercial forced air zoning systems since 1964. All of our products are proudly made in the US. My name is Steve Wood. I am Regional Manager for EWC Controls. In the App Store, search and download EWC Controls. This app will give you access to many things, including building a zone system. Based on the information you give us, we will select control panel, supply damper, thermostats, transformers, and bypass dampers. Furthermore, we have a bypass calculator. We not only select that bypass, but we select the size for you. You can contact us through the app. We also have at your disposal, anywhere, anytime, manuals to anything in our lineup. Our tech support, our team of engineers, we'd like you to use them and stress that you use them for on-the-job support, on-the-job, time-sensitive troubleshooting diagnostic support. If they're not available for the hours that you see, please direct it to Scott, Chrisanne, or myself, as well as any other support that you need. Why are we zoning? Why are we here? Well, we're here, first of all, to learn more about and understand better a zone control system. Secondly, why are we zoning? We're zoning because we have marketed ourselves as comfort solution people. We are here and we're offering zoning because we want to provide our customer comfort and savings. Last, we are here to make more money. Good margins in forced air zoning. I hope you're getting them. There are a lot of alternatives, none of them as complete as a forced air zoning system working with your existing distribution system that provides heating and cooling and IAQ to your household. Let's not lose sight of the concept of zoning. Zoning in a house is based on the fact that no house, no structure has the entire same load at the entire same time. None have the same demand. This allows us, zoning allows us to direct heating and cooling and to focus on the area of structure that is under load and not overcondition those areas that are not. On today's topic, the elephant in the room. Yes, we refer to bypass dampers as the elephant in the room on some occasion. It is the most feared, if you will, misunderstood part of a forced air zone system, even to the point where some contractors are reluctant to take on zoning simply because they don't understand what you do to relieve excess air. To get into bypass and bypass dampers, you have to understand airflow. Now, an airflow system is designed to produce a certain CFM to maximize the efficiency of your equipment's designed operation. The ductwork itself is designed to deliver that proper CFM to all areas of need. Now, our job is to maintain those same parameters when we utilize a zone system. So we not only enhance that operation and enhance the equipment, but we enhance the comfort of the homeowner. A properly set up zone system will ensure that the equipment doesn't even know there's a zone system on it. Today's equipment is different than yesterday's equipment. It is not as forgiving. And it's extremely important that the airflow and static is controlled precisely, and so we maintain proper operation and efficiency. To put that zone system together and understand airflow, we've got to look at these common sense rules of thumb, and that is putting together a zone system. Select areas with similarities, heating and cooling demands, living areas versus sleeping areas. Capacity of rooms will have a different demand. Possibly appliances or heat generating equipment of any kind will have different demands. Understand those and lump those together as similarities. Floor levels are definitely a different demand. occupied, unoccupied areas. How long during a 24-hour period are areas consistently occupied, unoccupied, which qualifies them then for savings as a zone. And exposure direction, east, west, north, south, different demands during the entire day in those areas. Design the zone system, we need to keep in mind good air distribution principles. That means we do not throw duct sizing 101 out the window when we add a zone system. Maintain those statics, maintain those common airflow methods that we learned and apply them to a zone system. We've got to consider existing and future living styles when we're doing a zone system. What may be happening today may not be happening tomorrow. Occupancy today may not be what occupancy tomorrow is within these homes. And to maintain equipment performance, we need to minimize the number of zones. We cannot give every area of a home, every bedroom of a home, every room of a home its own thermostat. The principles that we must base that on is the equipment that we're using. How will that work with minimum zones and bypass? Single stage equipment requires that no zone be less than 35% of the total CFM. Multi-stage no less than 25% of the total CFM. And modulating inverter 20 to 25% of the total CFM. What does that mean? On a 1,000 CFM system, 2.5 ton, 350 CFM is the smallest a zone can be with single stage, 250 with multi-stage, and 200 to 250 with modulating inverter. Going back to duct sizing, deliver 800 to 850 feet per minute. Design that duct 0.06, 0.07 in that range. Do not design your duct system with 1,000 feet per minute with a 0.1 static. To understand the examples of the minimal zone sizing, we look at single stage furnace and air system, and you've always got to look at the entire system. These are both single stage. We need 35% or 350 CFM, minimum zone. Multi-stage, as long as we have a single stage piece of equipment as part of that system, it does not matter that there's a multi-stage furnace. We need to look at that as a single stage system, and again, we're at 35%. Once we get into full multi-stage in both pieces of equipment, now that lowers our minimum to a 25% or 250 CFM. If we look at the Daikin equipment, the same thing applies to single stage furnace and air. The same thing applies if we're not a total multi-stage. We have to use it as a single stage system to do our figuring in both furnace and AC. If we're in multi-stage, we're at the same juncture. We can now look at 250 CFM as our minimal zone size. Continuing with the Daikin equipment, yeah, it's great we have a modulating furnace, but we're still looking at single stage AC or heat pump. It's a single stage system. Modulating and multi-stage means we have to look at the multi-stage. That's our minimal operating speed with this system. We have to look at 25% of the CFM, 70% operation in first stage. Multi-stage furnace and inverter, same thing, 25%. We have to look at the inverter, will go lower than the 70%, but we have a multi-stage furnace that becomes the dominant figure when we're looking at minimal zones. When we're looking at full modulation, modulating furnace and inverter, we can get down to 40% with the inverter. We get down to 60% with the modulating furnace. 60% becomes the number that we do our math with. And last is once we incorporate a heat pump with an air handler and strip heat, we're looking at full CFM at that point, and we're back to 35%, and that should read 350 CFM. What is a bypass in a zone system? A bypass is just that. It's a method that's used to relieve excess air. Where does the excess air, where does the air go to? Goes to a bypass area. That bypass is also there to maintain static in the system. How is all this achieved? It's achieved, bypass is achieved using a bypass damper. So let's look at a zone system. And let's look at ductwork. So we've built this zone system, or we built this duct system very straightforward. We have a 14x8 going upstairs and a 14x8 serving downstairs. Both those sizes were determined using the 0.07 static. That means 600 CFM is going to both levels. This is a 3-ton, 1200 CFM application. I decided I'd like to zone this system. Very simply, I now put a zone damper leading to the second floor, and I put a zone damper ahead of the supply leading to the first floor. At any given time, one of those could call by itself. In this case, zone 2 called for cooling. I cut off 600 CFM, or my downstairs trunk, and now I am trying to deliver all 1200 CFM through a 600 CFM zone. Not possible. What is done out there and what is being done to this day is a lot of people have bought into the concept that their grandfather's grandfather told them that when it comes to zoning, instead of bypassing, size your ductwork larger, somewhere in the figure of 70 to 80% of the total CFM, and you'll be just fine. Let me show you what happens. Take that 1200 CFM system, and I'll go split it down the middle, 75%. I need to have 1200 of that be delivered in a 75% value. So that'll give me 900 CFM per zone, per damper, per area. On a 2-zone system, that means 900 CFM per zone. I now have to increase my duct from 14x8 to 18x8 to carry that 900 CFM. So I've now decided that when zone 2 calls for cooling, I don't have enough duct to deliver 1200 CFM, but I've got enough to deliver 75% of that, or 900 CFM. And that works just fine. It's not that loud. Everything keeps running and this call gets taken care of. My zone 1 calls, I have the same process taking place. Let's just say that works and I can operate in that fashion. First of all, there should be no reason that a zone system in a duct system should be louder. Not louder to the equipment, not louder blower, and certainly not louder to the customer. In fact, a zone system installed into a system should allow that system to run quieter. Secondly, what happens when I've done my homework this way? What happens when both zones call? Because they will call in extreme conditions. There will be some overlap, numerous opportunities for both systems to call. I have 900 going out each direction. I have a 1200 CFM blower. 1800 CFM my duct system is built for. I have no performance anymore. My static is gone. My call takes longer to satisfy. I've destroyed that duct system in this case. That's on a 2-zone system. What happens when we get into a 3-zone system? A 3-zone system just quite simply cannot be set up without a bypass. Here's what happens on a 3-zone system. Using all that same math, each one of my zones has to be able to carry, once again, 70 to 80% of the total CFM. That means each one has to carry 900 CFM. So I need 3 ducts capable of that, 3 ducts, 18x8. What happens when I have all three ducts calling, all three zones calling at the same time? 900 times 3, 2,700 CFM with a 1,200 CFM blower. End of story. What's the answer? Bypass. Bypass is doing just this. It's sized and installed to handle the 600 CFM, the excess static, excess airflow, into a bypass duct and send that back into the system. The bypass air is kept to a minimum in all cases. This is showing it with a 2-zone system. And here's a couple different applications. The first one was sending that bypass directly across into the return drop in an upflow application. And here is just a top view of a bypass duct running from the supply plenum to the return plenum. Now I want that bypass duct to be the first trunk or the first duct off my plenum. So that has to be prior to any damper, prior to any main trunk line running off that plenum. It is reintroduced into the return air as far away as possible, at least up to 6 feet. And I return that into the system prior to anything before that system, prior to the space, to the air filter, and prior to re-entering my air handler furnace. If at all possible, over 6 feet, but 6 feet is acceptable. So at EWC, we take all this very seriously. We're here to support the distributors, the contractors, and the homeowners who want the best in comfort, who want their equipment to and systems, forced air systems, to run efficiently and provide comfort. What did we do? Well, hands down, we developed the simplest and most well-constructed and accurate bypass damper in the industry to make sure we get this done. It's a combination Belimo motor and built-in manometer pressure regulator, which you can see is located at the bottom of the Belimo motor. This will monitor and maintain the design static of any system in all modes. Now it comes with the pitot fittings and the tubing, and simply requires that you do a normal installation of a bypass damper, install those pitot tubes and pitot fittings, and wire it to a transformer. And yeah, that's right, it does not connect to any zone panel. In fact, to be honest, it could care less if it's in a zone system at all. Its job, quite simply, is to keep a law and order with the airflow and static of that system. That means it'll work independently of any zone system. It'll work with all competitive zone systems, and it'll give you operation in all modes of that equipment. And here's the installation. We're showing it here installed in a bypass duct. We're connecting our pitot fittings, pitot tube to the duct system. We're putting this within 2 feet and after everything, meaning after your AC coil, after any heat strip, and after any hot water coil on the supply side. On the return side, the negative side, prior to the air filter. Once we have that in place, we turn our blower on, put it on the highest operating speed for that system, make sure all of our zone dampers are open, make sure our air filter is clean. We want optimum static readings. Give that system 5 to 10 minutes to pressurize. You'll come over to that motor and you'll see a constant green power light. Below that, you will see a flashing orange light. use the screwdriver that comes with the zone panel or the head of a pen or pencil and press that button in. At that time, this goes into its own setup. Its own setup goes like so. It closes itself, captures a static, burns that into a chip. Then it opens itself wide open, captures that static, burns it into the chip. What it's looking for is a 10% differential. Once it sees that, you'll come back to that motor 3 to 4 minutes later. That flashing light will be out. That means you're set to go. And this will now control the static in that system going forward. Even if you were to lose power, the static that it registered will stay in place. If you need to reset it for any reason, pull the tubes off the motor, run it through a test. It will go back into a default setting because it does not see the pressure drop. At that time, hook the tubes back up and run a test again. Just when you thought it got to be the best, we enhanced it. And we enhanced it, and these are now shipping within the last week. And this is the SBD2 bypass. Now the SBD2 is going to look very, very similar to the old SBD. It functions and operates exactly the same. It sets itself up. All of the installation we just spoke about is the same. The difference is this. This now comes with NFC near field control wireless interface protocol. What is that? That gives you the ability to download an app on your iOS or Android from Belimo and have a visual of what's going on with your bypass. How do you do that? The way you need to do that right now is you hold that phone up to that motor when you have that app open, and that will give you different information. That'll give you the system static pressure. You can watch the system static pressure occur, or you can take a snapshot and take a look at it. It'll give you the system static set point, and it gives you the ability to change that set point. Most importantly, that's what the upgrade, the enhancement is from this SBD to the previous SBD, is I'm now able to adjust that static set point. Why would I need to do that? Probably one of two reasons. You have installed this into an existing bad duct system, or you've sized your bypass too large and it will not see the 10% differential. At that point, go in, select your static, and this thing will set up. It will also give you bypass damper position, total hours of bypass damper activity, and then, if you wish, the total hours of fan activity since it's been installed. Now, very soon, there will be an NFC to Bluetooth adapter. Now, what this adapter will allow you to do, and I highly suggest that you use this as a tool, attach that to the motor, mount it on the motor of the bypass damper. This allows you to do remote reads and remote visuals of what's going on. I do not have to hold that phone right to the motor during the process. So in distances that are very similar to most Bluetooth wireless products, that's how you'll be able to observe, change, or access the bypass damper. It also has a feature on it that once you capture any of this information, you can email this back to the office where they may keep it on file and have access to it. This will be available shortly. And when I say this, I mean the field adapter will be available shortly. And to tell you how proud of this we are, we not only won a silver award back in 2016 when it was released, This is an ACHR Dealer Design Award, but we won a silver award again a month ago when the SBD2 was introduced. Now, for any reason, and I'm thinking of budget, or you're looking at a larger number of homes for new construction, you're looking at getting by without going to the high end of the best bypass damper made, we do have mechanical bypass dampers, both round and rectangular. Now the electronic, the SBD, is available in sizes 8 to 20 and 6 different pre-made sizes in rectangular. The round damper, mechanical damper, CLBD, is available in 8 to 16 and the rectangular damper in 6 different ranges. So the rectangular damper still utilizes the arm and weight, meaning I've got to adjust my bypass damper blade based on the location of my arm and adjusting a weight up and down that arm. The CLBD incorporates a whole different style. We now eliminated the arm and weight, and we incorporate a very strong magnet with a very strong spring. So what we're doing is holding the bypass damper blade closed by means of a magnet. Once we reach or exceed the static that is set on our bypass damper, which is done with a thumb screw, and you'll notice the scale on the left of that faceplate, we choose our bypass, and once we exceed that, the magnet releases that blade, and now we're being held by the spring. And the spring is there to keep that damper blade from going all the way open and only going open as far as it needs to relieve static, relieve excess airflow. The window on the right of that faceplate gives you our damper location. Now this will allow that blade to come open and also hold it shut when the design static is achieved. Now, the kicker, when we're doing any type of mechanical bypass, we need to install a hand damper, maybe more commonly known as a balancing damper. We need to incorporate that into the bypass duct. And why do we do that? Well, in a bypass is another supply duct. We've balanced the rest of the system. This is the first one off. This has to be balanced as well. If we don't balance that, the air takes the path of least resistance, which will be this bypass duct, and it will race around there, stealing velocity and airflow to our zones, and also at the other end, supplying so much return air that we don't pull proper return air from the structure. So we need to install this balancing damper and or hand damper before it re-enters the return air. How do we do that? Well, we've got to take this bypass duct out of the system first of all. So we close the bypass damper and we close the balancing damper. We make sure all of our zones are open. We run the blower system, and we get our external static pressure at that and get our reading at that point. Here we're showing a 0.51. Now we need to set things up, bring the bypass duct into the equation. So we close all dampers but our smallest, which in this case is zone 2. We open our bypass and we slowly open our bypass, or excuse me, our balancing damper until we achieve the same 0.51 or very, very close as we did with the other test. Once we do that, we lock this into position. If you do not happen to have a manometer on the job, set this thing approximately half open It'll be close to achieving what you want it to achieve. I'm telling you, you need to do this. If you have any existing issues out there with calls not being satisfied or with excessive cycling going on, go out there and either change this out, preferably to an SBD, or introduce a balancing damper or hand damper to that bypass duct, because we are sending air around this bypass duct at speeds up to twice to 3 times to 4 times the amount of feet per minute that air is going out to our duct system. Because, like I said, air is taking the path of least resistance. So we can do all that. And then the question is, which the question always arises, okay, sure, you make the best of the best. What's the cost involved here? I often like to say, you know what, it's cheaper. If you want to get down to it, it's cheaper to go with the SBD, the electronic smart bypass. And here's why. The time and labor it takes to properly set up that old conventional bypass. And remember, you're setting it up for one mode of operation. And you may still leave that installation scratching your head and wondering if you've got it set up correctly. No setup in the SBD. The cost of the hand damper and or balancing damper, and then you have the time and labor to set it up properly. Got to have that manometer on the site. And then, of course, the callbacks. You know, this is a crime in any world, the HVAC world especially, to have to go back on jobs. And I'll tell you this, that north of 80% of all callbacks on a forced air zoning system, if it's not some kind of a wiring issue, it is most notably always airflow issues. And if there's a bypass in there, it's possible that's done incorrectly, or there's no bypass at all. That will eat up the difference in cost in a heartbeat. And let's just say you do find a problem, or you do elect to change it or take care of it in the proper way. You've got the added expense, most likely. It is going to be awful hard to go back in and correct that problem with the proper product and charge for that. And lastly, what's more value than to get the job done right? Have peace of mind that when you leave that, I'm not going back on that system, and it will continue to operate properly going forward in any and all modes of operation. So you choose. You choose which damper you want to use. And by the way, you do not need a hand damper for the SBD. The SBD has a unique curve design with baffles on this blade that create the same type of restriction that a balancing damper does. No need to go through all of that. So let's do some bypass sizing. We're going to do it longhand because we know, of course, we can use the bypass app calculator and that'll do it for us. Let's see where that comes from. So we take a typical 2-story home. We're going to do a straightforward 2-zone system. Zone 1 is our first floor. We're going to apply 100 CFM value to each outlet, except the bathroom. We're going to give that a 50 CFM value. Same with upstairs. Each value of 100, bathroom is 50. There's our 2 zones, 2 thermostats located in those zones. So first floor, we're looking at a 3-ton system here, 1200 CFM, single stage equipment. Let's go straight forward, single stage equipment, and see what we're looking at. Floor 1 was 750 CFM. Floor 2, 450 CFM. Now we've got a size of bypass, in this particular case, capable of handling worst case scenario. Worst case scenario would be when I'm shutting off the extreme or the most airflow during operation. This would easily detectable that we're going to get a call in floor 2, zone 2, 450 CFM, I've got to have a way to accommodate the additional 750 CFM. Go to my charts. They're available in all our material, including the website. That does the homework for you. We, of course, know that my bypass calculator on my app will do this work for me too. You will see that a 10-inch bypass in round carries the 750. In the rectangular, my smallest bypass is 12 by 8. Let's look at the multi-stage. A little different consideration here. First of all, I'm able to use first stage CFM because my UT3000 will satisfy my zones, any one of those zones, in a normal operation without calling for second stage. That means I can now look at first stage only. Now, quite often people believe that once I get into this communicating equipment, whether it be multi-stage or modulating inverter, that I don't need a bypass anymore. The straight down and dirty is my lowest fan operating speed in a multi-stage system, a two-stage system, is 70%. That means no zone could be smaller than 70% if you did not want to use a bypass. Otherwise, I've got excess air that I'm not getting rid of, and I've got static issues, and I've got noise. So let's stay with the program. I'm looking at 70%, or I'm looking at 840 CFM as my total in my bypass figure now. 750, my 450. Now I only need to accommodate 390 CFM. Remember, we had talked about minimizing the need for CFM, or excuse me, minimizing the need for bypass. We did not talk about eliminating bypass. We talked about the responsibility to not run with bypass just because it's a great bypass damper is available. Let's still try to keep the bypass to minimums. So now I'm only need is to get rid of 390 CFM. If I look at the mod and inverter, and most would like to think that I won't need a bypass, truth is 60% with the mod furnace is the lowest fan operating CFM. With the inverter, I go down to 40, but that doesn't help during the heating mode. So I use 60%, which lowers it to a little bit more than a multi-stage. I'm down to about 720 CFM now. Zone 1, zone 2. Now I'm down to 270 CFM is all I need to bypass. Some would say I will try to get by without doing that. Remember that sinister callback? My point is I would still recommend bypass. You sure it won't? Bypass won't operate when my zone 1 is calling, but zone 2 and zone 1 could. Zone 1 is generally based on the zone weight we gave it and a high degree of setback. I could get into second stage. What happens if I did and I didn't have a bypass? So use a bypass, 270 CFM. So in my multi-stage and my inverter and mod, I'm down to the smallest bypass damper in both cases. So let's look at one more exercise with 3 zones. Let's step it up a little bit. So zone 1, the extra bedroom's 350. Excuse me, one zone is 350. The main area is 500 and the master side of the house is 350 CFM, one large ranch. Same 3-ton, 1200 CFM system, single stage. I have to go with worst case scenario. I'll account for the remaining CFM in worst case scenario, which is smallest zone calling. That means 850 CFM has to be accounted for. Go to my bypass charts. I can cover it with my rectangular. I'm looking at a 10 or 12 here. I could possibly squeeze a 12 in, but do I want to go 12 or go with a 10-inch and try to make that work? Well, here's one thing we didn't discuss, and that's the ability to move our setting on our closed position on our motor. So we can move that so that the dampers that are not calling remain 10 to 15% open. What does that do? That allows for some excess airflow to go into those zones, and it's minimal so that we don't overshoot, undershoot those temperatures, nor will you feel that airflow on those registers. That would allow me to make up that extra 100 CFM, so I could then go with the 750 CFM. I caution you not to do that in smaller, very, very sensitive zones, but in the larger open areas, minimal open position, minimal closed position is advisable. If we look at the multi-stage, in this particular case, now we're looking at our smallest zone, one of those 350s. We subtract 350 from 840, not 1200. Drastically reduces us from 850 in a single stage operation down to 490. In the mod inverter, which takes us a little bit lower, 60%, I'm taking my 350 from 720. I'm down to 370 CFM. In all cases, we've lowered the bypass CFM, minimized a bypass CFM. This means my 8-inch bypass will work in both cases. Remember too, I always have this as an opportunity to do before or after I put my bypass in. If I put my bypass in, I can ahead of time, based on opening this a little bit, then I've done my math using it. If I get my bypass damper in and to the ear, I'm hearing a little bit of unnecessary whistle or noise, if you will, air noise, maybe I go to that motor at that point and I crack it 10 to 15%. That will eliminate that issue as well. So you have the option before and after. Remember to keep in mind, best to do that in larger areas that are less sensitive. We also have what we could, let's call a wild zone. A wild zone is an area or a room that you serve with airflow, but you do not have a damper on that particular outlet. Now, I'm not advocating a number of wild zones. Like in this case, I'm showing everything in green, foyer, bath, and laundry as a wild zone. I'm saying those are areas that you could choose one or more. In most cases, one wild zone will help you reduce, maybe in some cases, eliminate bypass, but most importantly, let's think on the grounds of reducing bypass CFM. And I can incorporate one of those areas. They're less sensitive areas. My foyer, which is subject to a lot of heating and cooling demands by the front door, not a sensitive area. An inside bath with no bath or shower, a laundry room, a larger laundry room, or smaller, one with one outlet, is not a very sensitive area. That would allow me to have my other 4 zones, my bath, my master, my bedrooms, my sunroom, kitchen, and my family and living area on their own zones, and incorporate that wild zone with them on every one of those calls. Every call that it gets qualifies that a little bit better if I have a wild zone that I'm also taking into account in the math. Be careful with wild zones. Make sure that you're not going to get into an area that's going to be sensitive to overheating or overcooling. But I can tell you, we've done this. I've done designs using wild zones and they've worked great. If you have an area that's too small to fit on any zone on its own, even incorporating wild zones or even incorporating a minimal position on my motor, and it's an area that is not used all the time, so it would really benefit if it would not have to be calling for heating or cooling at all times. I think of a bonus room as a perfect example. Install a damper to that area, install a thermostat to that area, install a transformer to provide power to one or both of those items, and my damper will open and close based on the thermostat. Now, I will not energize equipment in this case, but I will open if I need to based on my setting, and I will wait for a heating or cooling call in other areas of that house. Now, let's be honest, if that bonus room is calling for heating or cooling, it's not going to be ignored for very long because you will have calls in other parts of the house. This ends the bypass training. I thank you very much and hope to see you at future training classes.